So hello everyone, I welcome you all to this amazing platform of PW Gulf, and this is your math educator Shivangi Rajput, and in this particular video we are going to cover our Heron's formula in one single shot. We are going to learn about the formulas that are being used in this particular chapter along with some important questions that are there in this chapter. So let's begin with it. So this is our today's target, that is our table of content for today. We are going to go ahead with introduction. We are going to learn about Heron's formula, that what is Heron's formula, how to apply it in certain questions, and then we are going to practice some questions from this chapter. So the very first thing that we are already aware about is the area of triangle. Right? So in our junior classes, we have already learnt about the area of triangle as half into base into height. Right? So basically that formula is generally used in such triangles where the height is already known to you. Right? That can be a right angle triangle where the perpendicular and base can be taken as base into height. Another thing is that for any triangle that we have, for example, which is not even a right angle triangle, we are given with the specific height of the triangle and the height corresponding base is taken in half into base into height. Now, Heron's formula deals with question where the height is not given to us, right? Where the triangle is given to us and the three sides of that triangle are known to us. So, with the help of those three sides, which three sides are apart from that of height? So, we are going to learn about how to calculate the area of the triangle using those three sides. So, let's start with our Heron's formula. So, this is what a Heron's formula looks like, that is under root of S minus a, s minus b into s minus c. Now you people might be wondering what is this s, what is this a, b and c. So let's learn about it, right? So over here we have that if any triangle is known to us, right? So we are taking the three different sides of this particular triangle as A, B and C. Let this be small a, let this be small b and let this be small c. So A, B and C, so these are the three different sides that are known to us of a given triangle. So how do we start to apply Heron's formula for such given triangle? The very first step, student, is that we calculate a semi-perimeter. Let us begin with it. So for example, an unknown triangle is given to us with three different sides as A, B and C. The very first step to calculate the area of this particular triangle when only the sides are known to us is, first of all, we have to calculate the semi-perimeter for this triangle. That is S. And S is C. We know that a circle is a full circle, right? And a semicircle is half of a circle. We know that perimeter is what? The boundary of any object, any figure that is given to us. And what will be semi-perimeter? The half of that perimeter. So when we have to calculate the semi-perimeter, first of all, we should know how to calculate the perimeter. So for this triangle, the perimeter can simply be calculated by sum of all sides. Right. Semi-perimeter includes what? This boundary, isn't it? So basically what we are about to calculate is this boundary, and this boundary is what? A plus B plus C, which is equivalent to side A plus side B plus side C. And when I talk about semi means half of it, that is divided by 2. So the very first step is to calculate the semi-perimeter for any of the triangle that is given to us. The second thing that we have over here is what? To calculate and put this semi-perimeter into a formula through which we can calculate the area of the triangle, right? So your area will be equivalent to, first of all, a big under root. In this under root, this semi-perimeter, that is S, multiplied by this semi-perimeter minus the first side of the triangle into this semi-perimeter minus the second side of the triangle into this semi-perimeter minus the third side of the triangle. So this is what the formula looks like after, first of all, we have calculated the semi-perimeter. A, B and C are respectively the given sides of the triangle, and they all are multiplied and forms under a root. Now let us try to apply this formula to a question. So over here the question says a traffic signal board indicating school ahead. So whenever we drive or whenever we are sitting also and whenever we are traveling, so basically we see certain, boards like this indicating both signal boards like for a U-turn or for a take left, for a non-U-turn and so on, right? So similarly, there was a traffic signal board indicating school ahead, like such a board, and it was written over here on this board, school ahead, right? And then is an equilateral triangle. So we know that equilateral triangle is a triangle with all sides equal and with the sides A. If this side is A, so this side will also be A and this particular side will also be the A side of the triangle. Find the area of the signal board using HERON'S formula. If its perimeter is 180 centimeter, what will be the area? The one thing that is given to us already is the perimeter, right? So perimeter is given to us, that is equals to 180 centimeter. What is perimeter, students? Sum of all sides. What does perimeter means? Sum of all sides, right? That means A plus A plus A. Why are we taking A plus A plus A? Because this is an equilateral triangle and all the sides of this particular triangle are same. So over here A plus A is equals to 180 centimeter. 3A is equals to 180 centimeter, right? And from A, that is the side of particular triangle, comes out to be 60 centimeter, right? Now the next step that we have to do, student, is to calculate the semi-perimeter, half of the perimeter. If the perimeter is 180 centimeters, so the semi-perimeter will be simply 180 divided by 2. And what is 180 divided by 2, students? This is simply 90. So we will be getting 90 as the semi-perimeter. So we have calculated the semi-perimeter. We have the respective sides of the equilateral triangle. Now what we have to do? We have to apply this into HERON'S formula. So now let's use HERON'S formula. So your area will be simply equals to under root of S minus A, S minus B and S minus C. So these are the three different sides that are available for us to calculate the area. Now let us substitute the value, students. Under root of semi-perimeter, that is 90. A, B and C are all 60. So semi-perimeter minus side into semi-perimeter minus side. So this is how it will look like for the formula. Now what we have over here is 90 minus 60 will give you 30, again 130 and again 130. Now as we all are aware about that, whatever in pair, if the prime number are in pair, they come out, right? And if any number we can take out of the root, we can take out. For example, over here, if we take this 90 and over here what we have, if we take this 3 as 3 into 10, we can write 3 as 3 into 10 respectively, right? So let's see. This is 90. Let's do it. So 90 can be written as simply, if I write down 90, so this can be written down as 9 into 10. This 3 can be written down as 3 into 10, 3 into 10 and 3 into 10. What you can also do is make a pair of it and take it out. You can also do that, right? So from here, if we can clearly see that this 10 and this 10 will come out. This 10 and this 10 can come out. This 3 and this 3 in a pair can come out. And 9 itself can come out as 3. So what we have outside the bracket is, from this 9 we have 3. 1, 2, 3, 4, 10. So we have 2 10 outside the under root, right? Then we have 3 and 3. So 1 3 outside. And we have one more 3 that is left under the root. So over here what we have, 3 3s are 9, 900 root 3 centimeter square will be the area of this particular signboard, which is indicating school ahead. So 900 centimeter square, 900 root 3 centimeter square will be the correct answer for this question. I hope this is clear with everyone. Let's move forward to our next question. So over here it says a triangular wall, side walls of a flyover have been used for advertisement, right? As we can see that this is the triangular part of the bridge and this is actually used for what? For advertisement purposes. Now the next thing that we have is the walls. The walls are 122 meters, 22 meters and 120 meters. The advertisement yield an earning of rupees 5,000 per meter square. That is for 1 meter square the cost is 5,000. Of course, we are dealing in term of area because meter square is already there per year. A company hired one of its wall for 3 months. How much rent did it pay? So the very first thing that we have to do is what? To calculate the area, and the costing can be done later on. So we have 122, 22 and 120, right? Let us assume that this is the triangle that we are having, right? So the sides of the triangle that we have over here is 122, 120 and 22. So we have 122, 120 and 22. So these are the sides of the triangle that we are dealing with. The very first step to calculate the semi-perimeter of this triangle. So the semi-perimeter will be equals to sum of all sides, that is 122 plus 120 plus 22 divided by 2. So over here we have 202, that is 4, 222, that is 6, and over here we have 1 and 1, that is 2. So we have 264 by 2, that is 132 centimeter, will be simply the semi-perimeter of the given triangle. The next thing that we have to calculate is the area now, students. So the area will be equals to under root of S, that is 132, S minus A, S minus B and S minus C. So this is how we are going to write down the A, B and C side along with the semi-perimeter that is known to us. Let us calculate the area now. Area is equals to under root of 132 will remain as it is. 132 minus 122 will give you what? Will give you 10. 132 minus 120 will give you what? 12, right? And over here you will be getting what? 100. 110. Right? So this is what we will be getting after the subtraction, after we are done with the subtraction part. Right? I hope this part is clear with everyone. Now the next thing that we are having over here is what? Over here we have to calculate the area. Right? Now let us see that how can we bifurcate it. We have to split it. So 132 can be written down as 10 into 11, or we can say 11 into 12, right? We can write this 132 as 11 into 12 because 11 into 11 is 121 and then add 11 to it, so 11 into 12. So 132 can be prime factorized, or we can say factorized as 11 into 12. Then we have 10 over here. We have 12 over here. And this 110 can be written as 11 into 10. See, instead of multiplying each and everything and then calculating its under root will be a task for you. So what I will suggest is, for all the number that you are able to see under the root, try to prime factorize it or just split it into such parts so that you can make pairs out of it. First of all, I can make 11 and 11, 12 and 12, 10 and 10. So everything will come out, that is 11, 12 and 10. So 11 into 12 is 132. So 1320 meter square will be the area that is for this particular triangle. That is 1320 meter square. Now the next part that we are dealing with is, the next part that we have to find out is simply how to find out that what is the total spent, right? How much the rent. So the very first thing is 5,000 meter per meter square per year, right? What all we know is that this advertisement, right? So the cost for 1 meter square is rupees 5,000 and this is for 12 months. Right? This is simply for 12 months. We have done the advertisement for 3 months. So unitary method has to be applied. 12 months is given, 3 months is asked. So first of all, we have to calculate it for 1 month. So for 12 months, if it is rupees 5,000 students, so for 1 month, it will be equals to 5,000 divided by 12. And if we have to say we have to calculate it for 3 months, so it will be 5,000 divided by 12 into 3. Over here we have 4. I hope this part is clear with everyone, right? We can simply cut it by 4 directly. So 4 ones are 4, then 10, 2s are 8, 5 and 0. So 1250, right? Rupees 1250 is what they charge for 3 months for per meter square. That is, for 1 meter square, the person has to pay rupees 1250. But over here we have to calculate as per the area that is known to us. So over here, what is the area of the advertisement part? That is 1320 meters square. So over here we have to calculate it for 1320 meter square. So this will simply be equals to 1320 into 1250. So this will give you the rupees that particular advertisement yields or have to pay the rent for the 3 given months. I hope this question is clear with everyone. Let's move forward to the next one. Alright, over here the question says us, find the area of triangle, two sides of which are 18 centimeter and 10 centimeter, and the perimeter is given to you as 42 centimeter. So the very first thing that is known to us is, out of 3 sides of this triangle, we are already given 2 sides, that is, one is 18 centimeter and let's say the other one is 10 centimeter. For example, we are not aware about the third side. Let's take this third side as x. The perimeter is given to us as 42 centimeter. We know that the perimeter is what? Sum of all sides, that is A plus B plus C, is given to you what? As 42 centimeter. Out of these 2 sides are already known, that is 18 plus 10. The third side is x and this is 42. So x will be equals to 42 minus 28. So the third side will come as 14 centimeter. Right? So this is the type of question that where 2 sides are given to us and the perimeter is known to us. So simply by subtracting the sum of those 2 sides from the perimeter can help us find out the third side. Now we have our x as 14 centimeter. Now simply begins the question by applying the formula, students. First of all, the semi-perimeter. The perimeter is already given to us, right? So the semi-perimeter will be 42 divided by 2, which will be equivalent to 21 centimeter. So over here we have what? That the semi-perimeter is equivalent to 21 centimeter that is given to us. The next thing, apply it into the HERON'S formula and directly calculate the answer. So the area will be equal to under root of S, that is 42. 42 minus 18, students, 42 minus 10, and then we have 42 minus 14. Right? So these are the 3 different sides and this is the given perimeter that we are already having. Semi-perimeter, that is 21. So let's take 21, right? So over here, let's given as 42, 42, 42. Let's take it as 21, 21, 21 and 21. Right? So we have to take the semi-perimeter, not the perimeter. Now what we have over here is under root of 21. Right? 21 minus 18 will simply give us 3. This will simply give us 11. And 21 minus 14 will simply give us what? 7. So this is what we will be getting. Now we have to look up for ways where we can split a number into 2 such parts where they can pair up and come out of your under root. So over here 21 can be written down as 7 into 3, students. Right, 1 3 is already present, 11 is there and 7 is there. So after the factorization of any number, we can clearly see now we can make pair. 7 and 7 over here, 3 and 3. So 21 will come out, 11 will remain under the root and 21 under root 11 centimeter square will be the area of this given triangle that is there in front of us. I hope this question is clear with everyone. Let's move forward to the next one. Over here what we have is the sides of a triangle. The sides of a triangle are in a ratio 12:17:25 and the perimeter is already given to us, that is 540. So whenever we have this ratio perspective, whenever we have this ratio part, you people are aware about that we always take the ratios as x, because we are not aware about that which is the factor or which is the number which have actually simplified this ratio into the simplest form. So what do we first of all have to take? We have to take these sides as x. So over here this will be 12x, over here this will be 17x, and over here it will be 25x, right? So the very first thing we did is what? To calculate the sides, and the perimeter is already known to us. First of all, we added this extra x. You can take any constant, you can take k, and then you can add these up, that is 12x plus 17x plus 25x gives you the sum, that is the perimeter, which is 540 centimeter in the question. Right? I hope this part is clear with everyone. The next thing that we are having is to calculate the value of x. So over here what we can simply do is we can calculate it. So we have 12 plus 17 plus 25, that is equivalent to our 540 centimeter. So we have to add them up. So let's add them up. So 12 plus 17 will simply become 29, and then we have 25, right? 4. So 54x. From here we have equals to 540, and the value of x comes out to be 10, right? So simply the value of your x comes out to be 10. So the sides become 120, 250 and 170. So what are the sides? 120, 170 and 250. Now the very first thing that we are already given, that is the perimeter. So from that perimeter we have to calculate the semi-perimeter. So the semi-perimeter will be equivalent to 540 divided by 2, which is equivalent to 270 centimeter. Now with all this information that is given to us, we just simply put all the data in the formula, that is the HERON'S formula, and then we can simply what? Calculate the answer for your area. So your area will be equivalent to under root of S, that is semi-perimeter 270. 270 minus 120, students. Then we have 270 minus 170. And then we are having 270 minus 250. Right? So this will be equivalent to under root of 270. 270 minus 120 will give you what? 0. 5 and 1, 150. Then over here we have 100 and over here we have 20. Now again, instead of multiplying, try to factorize it in such a way so that we can take numbers out of the under root. So right, so what we have? 270, 150. So over here we have 270 into 150 into 100 and into 20. So these are the numbers that we have. So 270 can be simply calculated as, for suppose let's say 27 into 10. 150 can be calculated as 15 into 10. Then we have 100 and then we have 20. So from here we can take 10 into 10, that is 100, and this 100. So we can take 100 out, right? 27 can be written as 3 into 3 into 3. 15 over here can be written as 3 into 5. This 100 we have already taken out, and 20 can be written as 2 into 2 into 5. So this is why we prime factorize it, students, so that we can make pairs out of it, and from that pair we can take out the numbers that are in use. The longest part in HERON'S formula lies in this particular step where we have to apply. We know the three sides, if the perimeter is given, if the ratio is given. So we have to at the end calculate the area if it is HERON'S formula. So the very first thing that you require is to know how to solve these things. Some people do what? They multiply each and everything and then calculate it. Or if the things are visible, okay, if you have two 90s, you can take one out. That is very basic. But even if the numbers are complex enough and you're not able to understand that which number should be taken out of the under root, so what you have to do is you have to simply just prime factorize it. After prime factorization, make pairs out of it, and then you can easily calculate it. See, over here we can make a pair of 3 and 3, 3 and 3, this 5 and this 5, and 2 and 2. So we have to multiply nothing inside the under root, right? So this will become 100 into 3 into 5 into 2. So 100 into 5, 500, 3 into 2, 6, 6 5s are 30, that is 3000, and it was in centimeter square. Let us check the units. So yes, it was in centimeter, so 3000 centimeter square will be the answer to this given question. I hope that this thing is clear with everyone, right? Let's move to the next question. And over here, the next question that we have is certain application of Heron's formula. Now, we have learned about how to calculate the area, how to calculate the semi-perimeter, and how to actually use it further, right? But where is it actually applicable in a day-to-day life? Let's learn about it. The very first question over here says is that an umbrella is made by stitching 10 triangular pieces of cloth of two different colors, that is pink and yellow over here, each piece measuring 20, 50 and 50. How much cloth of each color is required for the umbrella? Now what is given to us that there are basically 10 cloth together stitched. Over here you are able to see 5 and rest 5 are on the back side of the umbrella for sure, right? So these are 10 and out of these 10, 5 are yellow as we can see in the pattern and 5 will be pink. Right, this is as simple as that. So in this question they are asking us to calculate the cloth of each color that is required. So the very first thing, let us calculate the area because the area of the triangular pieces is same in each case, right? If I calculate the area of this particular pink, that will be equal to the area of the yellow and to the another pink again. So now the very first thing that we have to do is what? The very first thing is that we have to calculate the area of one single cloth. And let us assume that the one single cloth over here is for suppose like this with 50, 50 and 20 centimeter of area. Right? So the very first thing that we have to calculate is what? The semi-perimeter of this particular triangle that is there in front of us. The semi-perimeter will be equals to sum of all sides divided by 2. That is 120 divided by 2, which is equals to 60 centimeter. The next thing that we have to do is, students, to calculate the area of this one single triangular cloth. So area will be equivalent to under root of S, that is semi-perimeter, S minus 50, S minus 50 and S minus 20. So this is what will give us the area of one single triangular piece, right? 60. Over here we can write 60 as simply, if we bifurcate it, let us say 2 into 3 into 10, right? This is a 10, this is a 10 and this is, we can write 4 into 10, as simple as that. Now out of these we have to make pair, that which of them are making pair. So over here 4 can itself come out as 2, students, right? We have 10, 10 pair and 10, 10. So we have 2 pairs of 10. So basically 10 into 10 will come out and inside the bracket will be left with 2 into 3, that is under root of 6. So we have 200 root 6 centimeter square as the area of one triangular piece that is there in front of us. So this is for just one triangular piece that is given to us. Now what we have to find is, as we are aware about that there will be 5 pink triangular pieces that will be used to make the particular umbrella, and then there will be 5 yellow, right, triangular pieces that will be utilized to make the triangle, the umbrella, right? So basically if the area of one triangular piece is 200 root 6, so 5 will be 500 into 200 root 6, students, and this will also be equals to 5 into 200 root 6. So this will be equals to 1000 root 6 centimeter square and this will also be equals to 1000 root 6 centimeter square. So this is how we are supposed to do it, and we can calculate the area of each of the triangular cloth that is actually needed to find it, right? All right. Let's jump to one more question. Okay. So over here we have the perimeter of an equilateral triangle is 60 meter. The area is. Now the perimeter is given to us as 60 and it is for an equilateral triangle, that is sum of all sides is given to us, that is 60. So we know that each side will be 20, 20 and 20. Now simply we know that semi-perimeter will be 60 by 2 students. That will be 30 centimeter. Right. The sum of all sides is 60 and it is given that it is an equilateral triangle. So we can take that the particular length will be 20, 20, 20. Now over here area will be equals to under root of S, that is semi-perimeter. Semi-perimeter minus side, that is 20, 10, 10 and 10. This 30 can be splitted into 3 into 10 students, into 10, into 10 and into 10. Pair. So what we have? 100 root 3 centimeters square will be the area of the given equilateral triangle. That is 100 root 3 meters square. Sorry, it is in meters. So this is meter square. So option number D will be the correct answer for the question. Now this is one question for your practice and your homework, students. Heron's formula is easy until and unless you understand the language of the question. Right, comment down the answer. I will be more than happy to see that. And basically this is all about Heron's formula. This is one single formula, but you have to take care of what is asked in the question, the language of the question. But this is the only formula that is applicable in this chapter that you have to apply in each and every question. Right, so this was all about Heron's formula, an easy peasy chapter with one single usage of formula. But please make sure that you people are aware about how to use the Heron's formula, right? How to calculate the semi-perimeter for the thing, how to apply it, and how to prime factorize or just factorize the particular thing that are there in the under root, so that you can take out as a pair outside the root. So this was all about it. If you have any doubts, so please feel free to mention it down in the comments. I will be more than happy to help you. So thank you so much and have a great day ahead.